So we're going to take a look at how to use StatCrunch to carry out a two-mean hypothesis test. One thing that has come up in looking at StatCrunch is that there's a difference in how StatCrunch calculates degrees of freedom for the two-mean t-test than how we do it when we have to work by hand. So that actually will change the notation that I used for finding the p-value for our two-means hypothesis test. So let me explain what's going on here. Finding the degrees of freedom to use when you have a two-sample test is actually kind of complicated. And so our sort of conservative estimate for the degrees of freedom was to take the smaller of each sample size minus 1. So in the case of the BSc Sanford example, that was the smaller of 60 minus 1, which is 59, or 30 minus 1, which is 29. So as an estimate for the degrees of freedom, we would use 29, which is what I stated in the video when I worked through that example. So the complication is that that's not how technology typically finds the degrees of freedom for the two-sample test. It's a much more complicated formula, which would be a little bit of a pain to do by hand, but it's easy to do with StatCrunch. The issue is that it won't necessarily match up with hand calculations, and you need to be aware of that. If there was any discrepancy on a homework or exam problem, I would accept either. But let me run through the example to show you what's going on. So if I go to tstat two-sample with summary, I can enter all of the information for the problem. So the Sanford sample mean was 102, standard deviation 13, sample size 60, and then for BSc it was 110 for the sample mean, 10 for standard deviation, and 30 for the sample size. And I'm going to do a hypothesis test where the null is no difference and the alternative is not equal to. So I compute that. And this is where the p-value I used in the video for the example came from, this p-value of 0.0019. So I noted that on the board as twice the probability that the t statistic is less than or equal to minus 3.226. And that's correct, but I stated that that was for the t distribution with 29 degrees of freedom. That's not the degrees of freedom that's being used by the StatCrunch two-mean test. So this degrees of freedom, I think it's actually using something like 80, here it is, 73 degrees of freedom. So that comes from a sort of complicated calculation. But if I were to do the t-stat and use a t distribution with 29 degrees of freedom, I would get something slightly different. So let me show that. Calculator, t distribution, standard degrees of freedom 29, and minus 3.226. And when I calculate that, I get 0.0015-ish. And so if I doubled that for the two-sided test, I would get 0.003, which is slightly different from the 0.0019 used in the video for the example, because I took the result from the StatCrunch hypothesis test, which used a different degrees of freedom in the calculation. So if you were kind of following along by hand, but then went to StatCrunch to do the p-value separately, you would have gotten a 0.003 instead of 0.0019. Would lead to the same conclusion, and I would not of course, take off any points for either result. But in the video, I either should have had 0.003 for the p-value, or I should have noted the StatCrunch degrees of freedom as 73 point something for that t distribution. All right, so that is what I wanted to point out about the hypothesis test. Same thing applies when you go to find a confidence interval. Because StatCrunch uses different degrees of freedom, the critical value that StatCrunch would produce would lead to a slightly different confidence interval, even for the same confidence level. So if we take a look at what StatCrunch would produce for the confidence interval, it goes from minus 14.56 to minus 1.44, and that is very slightly different from the minus 14.8 to minus 1.2 that we got using the 29 degrees of freedom to get the critical value. All right, so just be aware that using the critical value from the minimum of N1 minus 1 and N2 minus 1 for the degrees of freedom will be slightly different than if you let StatCrunch do it for you, where the degrees of freedom is calculated in a much more complicated way and turns out to be 73. Okay, so that is going to do it for this StatCrunch, and may actually do it for the term. I'll see you in class.